Algebra 2, Lesson 34, Uniform Motion Problems, distance 1 plus k equals distance 2. Alright, so we're just expanding on our motion problems and increasing the types of problems. Originally we started with distance 1 equal to distance 2, then we did distance 1 plus distance 2 equals an overall distance, and now we're doing distance 1 plus a certain amount equals the length of distance 2. So the key thing here is our distance diagrams. You really do have to be drawing those so you can identify which type of equation you're going to be working with. So we go to our practice problem. They tell us Zane began the journey at 5 a.m. at 30 kilometers per hour. Trisha began to chase him at 7 a.m. at 40 kilometers per hour. And we know what time it was when Trisha got within 20 kilometers of Zane. So to draw our diagram, we've got our start point. And then we've got our endpoint, and we'll go ahead and go with distance of Zane. Alright, so who is it? Trisha, or T, is chasing Zane. Zane travels this distance, and Trisha begins chasing him, but she doesn't catch him. She gets within 20 kilometers of him. So that's where Trisha stops, that's where Zane stops. Distance sub t, distance sub z. So what we see here when we draw this problem is we see that if we add this amount to her distance, we are equal to the distance of Zane. So that's how we're going to write our equation. D sub t plus 20 equals d sub z. And then again, if you haven't memorized it by now, you're in trouble, but we're going to use our substitution of distance equals rate times time. So once we've got our distance equation, we substitute in terms of rate and time. So distance of t is going to become rate of t times time of t plus 20 equals rate of z times time of z. Hold on, my focus is getting a little blurry. Let's see if we can fix this. There we go, that's better. Okay, so we've got our distance equation. So now we're going to go, or we've got our equation in terms of rate and time. So now we're going to go back to the problem and see what we can fill in here. Now they tell us that Zane's traveling at 30 kilometers per hour, and she's traveling, or Trisha is traveling at 40. So rate of Zane is just going to be 30. So we're going to put 30 instead of that. And the rate of Trisha is going to be 40. From here, we have to figure out something with our times. Now, they tell us that Zane started traveling at 5 a.m. and Trisha started traveling at 7 a.m. And we got to know what time it was when she got within 20 kilometers of it. So we don't know what the end time is. But we do know that Zane has been traveling 2 hours longer than Trisha. So we can write a statement of equality there. So if we take the time of Z, we set it equal to the time of Trisha, which is not true. We have to find something that we can do to adjust this to make it true. So if he's been traveling 2 hours longer, if we add 2 hours to her time, they're now equal. So this is going to be the equation we're going to substitute. Instead of writing time of Z over here in our equation, I'll substitute for T plus 2. So our equation is now 40 times time of T plus 20 equals 30 times, parentheses, time of t plus 2. We can simplify this through distribution. We get 30 time of t plus 60. And we can start solving this equation now because we've only got one unknown. So we'll get all the t's on one side, all the whole numbers on the other. Subtract 20 from each side. Subtract 30 time of t from each side. And what we get is 10 time of t equals 40. Simply divide by 10, and we get time of t equals 4. Now, we could go back, substitute, find out the time of z, but if we read the problem, they just want to know what time it was when she got there. So, if we know that her time is 4 hours, and she started at 7 a.m., we add 4 hours to 7 a.m., and the time is 11 a.m. And that's your answer. So don't forget, when you're doing these problems, once you solve for your first unknown, go back to the problem and figure out what it is exactly that they want to know. So, because that can be very key. Sometimes they'll ask how long each person was traveling. Sometimes they'll ask what time it was when they got to that point. You just really don't know. So once you solve for your first unknown, always go back and check the problem to figure out what information you need to get once you find one of the unknowns.